Good afternoon, I'm Mr. Ish. Thank you for joining me. Let's look here at the decibel scale, which has very much to do with loudness and intensity of sound. L here being the loudness measured in decibels. The equation is L is equal to 10 multiplied by log of I and IO, which is a ratio of two components. The I here representing that numerator, which is the intensity of the sound that you're interested in. The IO in the denominator represents the reference value, as you can see, 1 times 10 to the minus 12. The units of intensity are watts over meter squared. The units of loudness is decibels. Everything here is based on log base 10. The normal hearing of the human ear is from a 0 to 120 decibels. You have to keep that in mind. Everything here is based on factor of 10. If you're looking at something which is 40 decibels and something which is basically 50 decibels, this 10 more decibels represents times 10 in terms of intensity, because everything again here is represented by a logarithmic base 10 scale. The best way to understand everything here is by means of a few questions, because the equation is already there, the formula, we just have to utilize it to our advantage. L, loudness, is equal to 10 multiplied by the logarithmic factor 10 of this quotient. That's all you're doing. Let's look at a few questions. We have a certain machine. How about this as our first question? A certain machine makes a noise, and that noise has an intensity of 1 times 10 to the minus 5 watts per meter square. We have to find the loudness. What is the loudness of this machine with regards to the perception of the human ear? You would put everything over here in the equation. You're calculating for L. L is equal to 10 times log base. If I'm not putting a base 10, we understand it's base 10. And then you're going to put everything here in the formula. I'm giving you this 1 times 10 to the minus 5, but you also have this reference 1 times 10 to the minus 12. You would have to do this computation, take the log of it, multiply by 10, and you get your value here in decibels. And it's not a difficult calculation. 1 exponent 5 negative divided by 1 exponent 12 minus, I'm going to do the log of this. When I do the log of this, I'm getting 7 times that 10, I'm getting 70. So this machine, which has a certain intensity, it has a certain noise it makes, or loudness, and that's 70 decibels. Remember, again, everything here is by factors of 10. It's just like the pH scale, where you're converting concentration into pH by means of the log base 10. Here you're converting intensity to loudness by base logarithmic 10 scale. Exactly the same. Let's look here at another question. Our next question is this: a girl is talking normally at a normal speaking tone, and her voice has a loudness of 50 decibels. We have to find the intensity of her voice, or in another way, we're finding the intensity of the sound wave which is being transmitted from her mouth into our ears. What is the intensity of that sound wave? Again, you're putting everything here into this basic equation. You have given the loudness, and that's 50, which is L, is equal to 10 log base 10. We're calculating for this numerator value, and we have this denominator IO, which is your 1 times 10 to the minus 12. That's all what it is. Here the units of our answer will be watts per meter square. All you have to do is this computation. Take 10 on the other side, you'll get 5. I have 5 is equal to, you take this 10 on the other side, you're getting 5. 5 is equal to log, we know it's base 10, I divided by this IO. I won't put this IO figure, we know what it is. Then I divided by IO is equal to, you're taking the log on the other side, you get 10 to the power of 5. That's exactly how it is. The log is going to go on the other side, you're going to bring the exponential base, which is 10. You'll do 10 exponent 5. You're getting 100,000. And then you're going to multiply it by the IO. Remember, the IO, the denominator, is going to go on the other side of multiply. We'll multiply here by 1 exponent 12 minus, I'm getting here 1 times 10 to the minus 7. The intensity of our voice, or the sound waves generating from our mouth, are 1 times 10 to the minus 7 watts per meter square. And that's a good answer, and it should be right. You can check your answer by doing exactly this computation in a reverse manner. I have the intensity of our voice divided by that reference, 1 exponent 12 minus, take the log of it, multiply by 10, and we'll get 50 decibels, which is exactly what we wanted. And we can do one more question here, and that'll be the end of this video. The last question is this: machine A, when it's operating, generates a certain loudness or noise, 110 decibels. Machine B generates a certain noise or a loudness of 40 decibels. How many times louder is A to B? When you look at this question, you know you're looking here at this part, I and IO. That's all you're doing. You're looking here at the ratio of both of these. You know, in all instances, L is equal to that. You can take the 10 on the other side. L over 10 is equal to the log base 10, this I and IO, the quotient of that. In each of these instances, for machine A, you're looking here at L divided by 10, which is 110 divided by 10. For machine B, you're looking at 40 divided by 10. What are you looking here at? 11. What are you looking here at? 4. All you gotta do here is now solve for the quotient. I over IO for machine A is equal to 10 to the power of 11. You're taking the log. On the other side, you're bringing in the exponential base 10. And then for machine B, you're doing I over IO here is equal to 10 to the power of 4. Now I just do 10 to the power of 11 divided by 10 to the power of 4. So you can see how much times louder this is to that. What are you going to do? You'll do 10 to the 11 minus 4, which is the laws of exponents. You're getting here 10 to the power of 7. And then when you want to open this up, you can. You'll have 7 zeros. 1, 2, 3, 4, 5, 6, 7. 10 million times louder. Machine A is 10 million times louder than machine B, simply because everything here runs on the base 10 logarithmic scale. And the answer is good. Everything here run by this ratio from the formula. And that right there will bring us to the end of this video. Thank you for watching.